So we now start video 2. Problem number 3. Probability that a regularly scheduled flight departs on time is P of D. D for departure. P of D equal to 0.83. The probability that it arrives on time is P of A equal to 0.82. And the probability that it departs and arrives on time, departs and arrives, that is intersection, P of D intersection A equal to 0.78. The question is, find the probability that a plane arrives on time given that, so these two terms, given that it departs on time. Also find P of A by D dash. So this is what is known as conditional probability. They are not simply asking find the probability that a plane arrives on time. Find the probability that a plane arrives on time given that it depends on time. So conditional probability. So solution. So there are two parts. Let us say this is part A and this is part B. Part A we will have to find P of probability that a plane arrives on time. Plane arrives on time means A given that it departs on time, D. So this conditional probability. P of A by D, we know the formula for conditional probability. P of A intersection D divided by P of D. Both are given. P of A intersection D is given as 0.78 and P of D is given as 0.83. If you use the calculator, you will be getting the answer 0.94. So conditional probability. Part B. Also find P of A by D dash. So this is what is the probability that it arrives on time given that it departs late. So P of A by D dash, once again the conditional probability formula is P of A intersection D dash divided by P of D dash. We know the formula for P of A intersection D dash as P of A minus P of A intersection D. P of D dash is 1 minus P of D. So substituting all the values, P of A is given as 0.82 minus P of A intersection D is 0.78 divided by 1 minus P of D is 0.83. 0.82 is 0.04 divided by 0.17. So this is approximately 1 by 4 nearly. You will be getting, use the calculator to get 0.24. So 0.24 is the probability that it arrives on time given that it departs late. So problem number 4, state Bayes theorem. This is one of the very important theorems in probability, conditional probability. So the statement may come in 2 marks question. State Bayes theorem on probability. So the statement goes like this: if B1, B2, etc. Bn are mutually exclusive and exhaustive. What is the meaning of mutually exclusive? I take, say for example, n is equal to 4. This is our sample space. The whole thing is our sample space. Let us take, say, this is event B1, this is B2, this is B3, this is B4. So nothing is common between these 4. So they are called mutually exclusive. Nothing is common. and they are exhaustive in the sense union of B1, B2, B3, B4 equal to the whole space, sample space will come. So mutually exclusive means BI intersection BJ equal to MT for I not equal to J, mutually exclusive. So exhaustive means union of all of them, I is equal to 1 to 4 is equal to the whole sample space S will come. Mutually exclusive and exhaustive. And we have A, B, any event. This is the event A. Now this part is A intersection B1. This part is A intersection B2. This part is A intersection B3. And this part is A intersection B4. Union of A intersection B1, A intersection B2, A intersection B3, A intersection B4 is whole of A. So therefore probable exhaustive, and if A is any event, then part 1, the total probability of the event A, P of A is given as, we will be getting P of A union B1 plus etc. If we put it in the sigma notation, sigma P of, we will be getting, these are all intersection, A intersection B1, A intersection B2, A intersection B3. So A intersection BI, I is equal to 1 to N. This is same as sigma I is equal to 1 to N P of A intersection BI. P of A intersection B, look at this one, P of A by B formula is what? P of A by B is P of A intersection B by P of B. So therefore what is P of A intersection B? P of A by B into P of B. Similarly here P of A intersection BI is P of A by BI into P of BI. So this is our first result. Total probability of the event A is sigma I equal to 1 to N P of A by BI into P of BI. The second result, very important result, is P of A is given. What is the probability that it is BI? P of B by AI. This is given by, denominator is P of A, numerator is BI by A. We will have to write it is B of A by BI into P of BI. So this is the result, P of BI by A. This P of A, of course, given by sigma I equal to 1 to N of this result. So this completes the statement of the Bayes theorem, and also this completes video 2.